right, so this is the Fuse 1 Plus 30 watt. So I'm going to walk you through slicing and printing your first print on the Fuse 1 Plus 30 watt. These machines, I will say, have been very impressive. Now, not just the fit and finish and the form of the actual machines. The industrial design is frankly beautiful, really well done. The software also is jam-packed with features that make everything more efficient, faster, just makes the workflow a breeze. Plus, they made it really easy to slice just about anything. So we're going to pack the build volume, then we're going to print them, and then we're going to take you through the entire sifting process, and then the blasting and depowdering final polishing process as well to the final part. I'm going to show you just how easy it really is. Now, we do, of course, sell all these at visionminer.com, so go there to check it out if you want to know more, and we support them too. So if you want to buy one of these systems, give us a call or shoot us an email. We're there to consult you and help you along the process. So we don't end the relationship the minute we ship the box. In fact, quite the opposite. Your success is our success. So on that note, let's just get right into it. The first step is always choose your printer. So maybe if you've got a Form 4, you'll need to switch over. Now, if you want to buy one of those, we also sell that. We're going to select the Fuse 1 Plus 30 watt, and then we've got Nylon 12 loaded. So we're going to click that. You get one layer thickness. Now, there are different speeds of printing. There's speed optimized, there's a legacy version or default. We're just going to stick to default for now. And of course, we will do the print job label that shows up on top of the print. So that's a pretty cool little feature. If you're doing production and you're just printing batch after batch after batch, you can set them to the side. You'll know what is in that build volume before you've unpowdered it. I'm going to go ahead and hit apply, and that will show me the Fuse build volume. I've got a bunch of parts right here that I have selected. So let's toss in the inserts. And then let's go ahead and take all of these parts. Now, I've got some NASA fabrics. These are actually two different versions of a brushless motor that we're actually going to wire and assemble. So make sure you're subscribed to see that content when it comes out. That's a future project. So I'm just going to go ahead and select all of these, dump those in there. It says there are a couple broken models, so it's going to repair it with Autodesk Fusion, which is fantastic. I don't have to actually do anything. It's just going to repair them on its own. And then it says some parts are too big to fit in their default orientation. So let's ignore and see what parts that was. Oh, it was the chainmail. All right, so this chainmail, oh no, the NASA fabric. So I just need to take this, and I've got these controls here on screen. Let's zoom in a little bit so I can rotate, I can move it. But what I want to do is go over to the Scale tab, and I'm just going to scale it down a little bit. 0.9 still a bit too long, so let's try 0.85. There we go. All right, that fits. Let's try that. And then let's go into the brakes, and I'm going to get all these brake parts. We're going to have a fully assemblable Brembo brake rotor. That'll be cool little part. Let's go back in there. Can't forget the main one, which is this SLS Rubik's Cube. It's a torture test, originally designed, I believe, for MJF. So I'm going to import the file that Formlabs made, and I am just going to hit one-click setup. Set up my print. And I'm going to lean back for maybe 15 to 20 seconds. Wait for this thing to calculate everything, the best place to put all the parts in the orientation. Here we go. That is a packed build volume. Look at this. Look at this. It even packed this part inside the motor. It put the cylinders flat, which is something you don't see on all machines out there. Even this cylinder, like this cylinder, we're going to see if that comes out round, right? Preview, hint, it does. Looks good to me. It's about a half a build volume, so I'm going to click down here, and that's going to calculate the total print time. The total powder for this build is going to be 5.35 liters, or 2.77 kilograms. The sintered part of that is going to be 0.79 liters, or 0.76 kilos. There's extra powder left over. We're at about 28% packing density, and you really want to get to about 30%. If you get to a 30% packing density, then you effectively reuse all your powder. If you're less than that, then you'll end up with a little bit of extra powder over time. But if you can get that packing density good enough, then you'll literally never have wasted powder. And there are 1,494 layers on this. The total time is 12 hours and 14 minutes, 43 minutes to pre-print, 10.5 hours of actual printing, and then less than an hour to cool down at 58 minutes. Nothing. What I can also do here is look at the actual layers. Come in here and drag up this slider, and we can see every layer. So this first layer is full, and then you got little NASA fabric things, and there's the case coming up, and it's just going through all these little parts. So now we got to turn on our printer and send this file over to it. I'm going to click this. There we go. There she is. Shows we're missing the build chamber because I haven't put that in there yet. But I'm going to apply, upload to queue. So while this is uploading, we can pretty much go over to the machine, make sure it has enough powder, make sure it's all set up, put the build chamber into it, and get it going. So we're going to do that right now. All right, so this is the Fuse 1 Plus 30 watt, and there's our print job right there. You can also go into the queue and see it's that one right there. Here we go. So we can check here. We don't have a build chamber, so let me slide this to open. As you can see, we do not have a build chamber. So open that up to get it ready. So now we got to get our build chamber into the Fuse. So there's a little clip on top here. I'm just going to pull that out, open that door, and then pull this puppy out. I'm just going to put it right back in here. Beautiful. Snap that in. And this, you want to make sure to orient this properly because there's actually a seal that it happens right in there. So there we go. It recognized the build chamber. Awesome. In the hopper, we've got less than 6 kilos. I think we needed like 5.7 for this, but we should add some powder just to make sure it's good. Over here, we've got the cartridge. You actually want to load your fresh powder into this little thing. Now, we haven't printed the part that actually makes it easier to fill through that yet, but this holds your fresh powder and it holds the sifted powder for redoing it. What you normally do is take this cartridge here, I'll just show you, and this puppy goes into this drawer right down here like this. So, boom, and then you just open the top, slide it in. All right, so now we don't have any sifted powder, we only have fresh powder. So if I wanted to go fill, I would actually say abort fill and then change the refresh rate to 0% to just fill it with fresh powder. But I don't actually need to do that, so I'm going to leave it at 30%, bring that down. I already have sifted powder in here, so I can close that back up. And what you always want to do is make sure that sifted powder is mixed with the fresh powder really well. I'm going to slot that in there. And then you just hit the mix button and it gives you a timer. Then you see that, that's just floating everything around, getting it really nice and mixed. Now we've already done this, so I'm gonna stop that. Let's go ahead and close this drawer here. I'm gonna grab my powder hopper. I'm gonna add it to the Fuse. I'm just gonna open this. I'm gonna position this right there on top. See, it slots in, so it's really secure. And then I'm just gonna, you can watch into that window, open the powder, open this little slot. And now it's gonna dump all that powder in there. Give it a couple whacks, and they say to leave it for a few minutes because you don't want powder going everywhere. It's in there, it's dusty, it's all floating around. We'll give it a little drum. And then close that, and then we're just gonna, good to go. And now I can put this down here so it's ready for the next time when we actually sift this print job on that puppy. Oh, really cool thing too. We'll show you all this later, but amazing lighting. This whole thing goes up, but we'll get to that later. So in here, we've got the powder. It'll update shortly, showing that we have more than 6 kilos of powder in there. All right, so I'm gonna go to my print jobs. I'm just gonna go to the, well, we got the queue there. I could hit that button or I can hit this button. Boom. Now we gotta prepare everything. So we're gonna hit begin and it's going to tell us to clean everything, which we did. Very good. Build chamber ready. Plugs well seated. Good to go. The infrared sensor needs to be cleaned before every print for accurate readings. So we're gonna open this top door up here. And you can see it right down there. Inside, it'll tell us to pull the cap out and inspect the lens. Just attached with a little Ethernet port, as you can see. But you examine it to see if it has any debris or haze or anything on it. It's looking good. So I think we're good for this. So I can go ahead and just put that right back down in there. Snaps closed the magnet, very nice. And next. Oh, I guess it had instructions for that. So you look at it, you pull the cap out, yada yada. Close the access door, good to go. It's now clean and ready to go. The powder level, the hopper on the right side should be filled. We just did that. So go ahead and open the lid of the hopper. Make sure it's filled to at least a 9. Yeah, we're good. Okay. And if you need to, do the cartridge thing that we just showed you. Very good. All right. That's it. We're ready. And now I'm just going to hit print. And that's all there is to it. We've got our print going. We're going to come back in about 12.5 hours, and then we'll take the chamber out, put it in there, watch the cake rise, depowder all the parts, and then put it into the Fuse Blast, which is fantastic. So we're going to let this thing print overnight, and we'll be right back. All right, and we're back. It's finished. It went overnight. It's the next morning. And here you can see it got the print label on top. So this just listed all our file names. I think if you give the job an actual name, it'll show that. And then our username down here, so you get Division Minor. So let's get ready to take this thing over into the Sift. But first, PPE. Now, nylon's not very toxic and questionable how much of this stuff you need, but if you want to be the safest possible, getting these filters and a face mask is always good. And then, of course, the gloves. I like wearing nitrile gloves, just a little bit of protectant. You don't have to wash your hands as much. All right. Okay, so first things first, we're gonna get the Sift ready to receive the build chamber. So we're gonna use this button here, turn on the light, and this is also going to start the flow of air in there so no powder gets out. We've got our parts bin. We're gonna use this for transferring into the blast. These are the included gloves, which are actually pretty good. They're really soft, so you're not gonna damage your parts. And they're really big and thick, so they got nice little hearts on them. Thank you, Formlabs. That's a nice little touch. But I like using the fidelity of nitrile, so we're just going to put these to the side for now. All right, so now we're ready to receive the build chamber. So we'll go right here, slide to open the door. Oh yeah, look at that. Oh, that's freaking cool. So first thing, open the door, and then take the plug out. Always remember, you got this little thing on top of the plug that goes like that, and then we're just gonna slide it out. Now I can remove this, so you can see it sliding in. We're gonna close the latch, and we're gonna plug this one in right down there so that it knows what it is. All right, so then you come down to our stream, and all we do is unpack. Here it comes. All right, beautiful. There it is. It came all the way up. So now, I want to show you how well this thing pulls the powder. Look at this. I can pull it there. There's no powder coming out. Look at that. That's great. We can start breaking our parts apart. Let's just move it on over this thing, and then we can hit the Sift button, and it's going to start running the sifter. Now this down here looks like that. So it's going to be vibrating to move all the unsintered powder down into the hopper, which then is going to fill our cartridge for the next print. So let's just, ooh, look at this. Look at that. That's cool. That's super neat. Very cool. And you use this as a parts bin, so we're just gonna start breaking it apart. Ooh, it's still kind of warm. This is the sensation. All right, so I got all these parts. I'm gonna just start putting the full things over here, and then I'll do more depowdering in a few moments. hot. I think there's a part inside this part. Yeah, look at that. That's the one we saw that was inside the other part, so that'll be interesting to get out. Okay. Here's our chainmail. There's our ball valve. There's our Brembo brake. Yep. Oh, this is one of those cases. Yeah. This really is like being in Indiana Jones or Jurassic Park or something. You know, being an archaeologist and digging up things, you're finding it's actually kind of a fun process. What I'm really glad is we don't have to manually sandblast all this, because the blast over there takes care of it all for you. So this is really the most labor-intensive part of the entire process, just getting them out. Depending on how much powder you want to save, you can be less or more thorough with this part of the process. Oh, here we go. Here's our NASA fabric, I believe. Ooh, this is one of those wrenches. All right, here we go. You ready? Oh, yeah. Dude, this is going to be interesting to depowder. Now that I got most of the parts out that I could find, oh, here's another one. We are going to take all this unspent powder and get it over the Sift. So let's take a look at that real quick. Let's take a look at this thing while we can. Look at that. It's like all in there, moving around, jumping around like crazy. This is just vibrating at a high rate. We'll keep this puppy on, keep scooping everything in. So now I got most of the powder cleaned up, the spare powder, we're gonna actually go deep onto these parts. So let's go into here and let's get one of these brake calipers out. I wanna save as much of the powder as possible because I can reuse that on the next build, so why not, right? So I'm just getting all the little nooks and crannies. As you can see here, I'll just go basic. I'll put them all on the left and then get the fine stuff, putting them back to the right. And these latches right here, I can actually break those free, get them moving, even this part. There we go. Oh, it looks like this went at an angle. So we should have checked that in the slice to see. So you can tell it just barely stair-stepped and it put the texture on the outside. So when we did the automatic setup, we're gonna go back and look at that in the slice and see what that turned out like. Oh, these are the bolts. I printed the bolts for the brake calipers. All right, now this part, ooh, look, we had two. And again, you can be as thorough or unthorough as you want, because once we throw this into the blast, no more powder will be recovered, but it will do all this work automatically, which is a massive, massive benefit. One of the biggest annoyances of SLS 3D printing can be the labor-intensive post-processing, which is why you want to make the investment in the blast. It is well worth it. All right, so here we go. This one's gonna be neat. Let's just get the outside flat edges first. Look at that beautiful, beautiful product result. Okay, now this is gonna be interesting because this is a block of chainmail designed for FDM 3D printing, not for SLS. In fact, if anybody out there has chainmail that will fit, like the biggest chainmail thing you could possibly find that will fit in the Fuse One, we will print it. So send us your entire like armor outfit in chainmail, but make sure it fits in the build volume and size and shape of the Fuse One Plus, and we will print it. But we need somebody to provide the file because we don't have one yet. So if that's you, hit us up in the comments or shoot us an email. Go to visionminer.com. I don't want to do too much with the metal because it will scrape the parts. But you see I can kind of get in there. I don't know exactly what this is going to be like to get apart, but okay, I know this outer thing comes off, so these are basically just trash. Probably let the blast do this one because that's pretty tough. Alright, I'm just going to get the rest of these. Oops, I broke it. I was too gnarly with it. Oh, this is the little one that's got all the little, it's a lattice structure. So we're gonna let the blast do most of this too. because getting in there is next to impossible. And this is another part that has moving parts. So we're gonna get a lot of the powder off, and we're gonna get a lot of the powder out when we go over to the fine, but then we're gonna actually twist this. This one is extra delicate. As you can see, we've got fine little chain links. Here's another one where we've got springs inside. So there's a bunch of powder to get out of here. All inside of it. Nice little bricks. This is the centerpiece for the entire Rubik's Cube. And you can even take this, hold it like that. Sometimes it's easier on small parts to hold the brush, so you just use it like a shoe brush. Ah, here we go. Let's get this guy out. This is the brushless motor housing. So this is an interesting one because we got a part inside a part. So we need to break all this powder free. That'll be another one for the small tools. Ah, yes, more NASA. This will be a cool one when it's done. Save that for later. Got some captured gears. Those should break loose. Now I'll leave a couple of these with some extra powder so you can just see how well the blast does on its own. Let's turn the Sift back on. Let's actually see how much stuff is in our Sift now because it's on automatic timer. Okay, so let's watch this. It only goes for about 10 minutes. So we'll hit Sift again. Look at this. Look at that go. How freaking cool is that? Use your fingers in this side thing. Get all this extra powder out of there. Let her go. This one's basically hollow too. There's another lattice structure. So I'll leave this one just full of powder so you guys can see what it looks like just going through. Oh no, there's a bunch of loose powder in there. Might as well recover it. Oh yeah, I can feel it. It's totally hollow. So I want to be gentle because these are thin, fine parts. Now we got a pig's head. Nice. Here, so you can't see any detail on that right now. I'll leave that like that for you guys. So if you can see that fine texture, this is a whole bunch of tiny little spires. So I'm just gonna do it a little bit more, but we're gonna let the blast handle most of that work so that we don't mess it up by manually doing it. Oh yeah, it's cotter pin, look at that. And I printed the cotter pin itself. So we've got the pin and then the cotter for it. The cotter pin and the cotter. Oh, I broke it. Oh no. All right, well, so little tiny parts like this in nylon 12. We're gonna be running a bunch of other materials through this machine. So subscribe so that you see that content when it comes out. And we're gonna be comparing a bunch of the different materials. As you can see, tiny little details should have been going through that. Yeah. All right, here we got another captured part. This is a moving part. So before I put it in the blast, I do sort of want to get it moving. Let's take one of these. Sort of get in there. Yeah, look at that. So whenever you have moving parts like this, it is captured powder in the joint. So you do want to try and get it out. And then if you run it through the blast, you can break it free after and run it again in the blast and you'll get a similar result. But the earlier you can do it, the better. There we go, free spinning. These are the pistons for the brake caliper. Here's another hinge, a living hinge. Well, not a living hinge, but a printed in place hinge. So if I take here, I can start breaking this. I can move it. Cool. Ah, and the internal for the small case they like to send out as samples. There we go. Little snap, and there's our booklet. All right, so I'll leave this is a thread and these are little tiny features, so I'm gonna leave this part with all this powder on it so I can show you exactly how well the blast does. So there's a bunch of details up in there and there, as you'll see shortly. Or this is a spiral spring. So this one, ooh, look at that. It already came apart. Look at that. Look at how insane that is. Oh my gosh. Now we gotta be gentle with this. Okay, so if you're wondering about how the blast handles delicate parts, well, this will be a great example, because I almost just broke it. So I'm just gonna let that thing go in the blast. All right, let's see if we can break this NASA stuff apart. All right, well, we're gonna leave the blast to this one too, because there's a lot of little details in there. We got our label that we'll put up on the wall. And of course, the last of the brushed motor part. Now this is an interesting part because it's very difficult to print in any other way than SLS. It's got so many fine details, floating regions, stuff like that. So you can print an SLS with zero support material. And that's a key. It's a big key because you can do geometries you could never do before. And you don't have to pay for ridiculous, insane, and injection mold costs. Let's move over to our fine tools. Sometimes I like grabbing this thing and just using it all. Should be able to go through the center of this. It's got most of the loose powder. We'll let the blast do that. So now I'm gonna take these parts, I'm gonna put them right here in the bin. NASA stuff. We got more of the NASA stuff. You know, I remember hearing some guy say once that when it comes down to it, you don't actually want to be super thorough if you have something like the blast, because the powder that's right next to the centered powder isn't the highest quality anymore, and you really want to recover mostly the powder that was, you know, like a few millimeters away from the parts. So it's not always ideal to like be super thorough on this. In fact, you don't want to be that thorough all the time. Sort of finding that in between. That's good. This one's good. We're gonna see what that does. We got the blast. We got the blast. We'll just blast it all. How about that? That's why we bought the dang thing, so we didn't have to do all this work manually anyway. And we'll call that good. We're good. Now this one, I do want to get some out of the center here. Let's see, so it turns this way. There we go. See that? Got that broken apart. That'll be a little bit nicer when it comes out of the blast. Cool. Okay, now we got to get this part out from inside of there. We probably don't have to, but I'd rather do that so the whole thing gets blasted nicely. Two sides free, and now the part is out. Okay, so now that we got this, we got powder everywhere. So I'm going to do a quick little cleanup. Put my tools up top, put all that stuff up there, dump this out. Start moving all this over. We really got to print the thing that goes over this. So normally this wouldn't actually be here. There's a case that you put over the top that makes it easier to fill and it lets the powder flow over. So we're going to be doing that in a future video here in the next few weeks or so. Again, if you want to see that, make sure you're subscribed. It helps the channel, helps us do more content like this. And if you really want to support the channel, then give us a call, shoot us an email, go to the website, visionminer.com, and buy something you want. We make all this content because we are a business. We do this for a living, and this is how we put food on the table and have a good time. So we appreciate all your views, all your comments, and we appreciate especially when you choose us for your vendor. Whatever industry, whatever size business, small business, multi-billion-dollar corporation. We work with everybody the same. It's all about relationships, helping you out, making sure you get what you need, and getting you set up. Look at how well this thing captures. Look, I'm gonna go like this, and all the powder just goes straight in. It's fantastic. So I'm gonna use this little brush, just sort of get some more stuff down into the sift here. I get all this powder out of the edges. So we will let that continue to sift, and as you can see, it says we now have 2 kilograms of sifted powder. Before it was 0. We've got 2 kilos of fresh powder, so if we refresh this at 30%, then we're going to end up with still some fresh powder left over. just put this back on for now. We've got all our parts depowdered, and we're gonna move them over to the blast here just to get them out of the way and clean up our station before we put everything into the blast. Okay, so this thing does open and close, but I'm gonna do the first part with it closed. I'm gonna basically get the Sift back on and get as much of this powder down in there as I can. And you can use the brush, you can use this little brush. Now this is probably not best practice, but I'm gonna open the fresh powder hopper just to empty the cap out and then close it immediately because I don't wanna contaminate the fresh powder. Okay, so now I can take the vacuum hose. That will automatically turn on the vacuum in the back. And now, as you can see, we can clean up. I'm gonna use this puppy right here. Let me actually turn that off. I'm gonna get this stuff out of there. You can sort of grab all this out. It does even out and become too thin, but I wanna get as much of that powder as I can, sifting into the Sift. Okay, then we can clean off our tray. Now you can also, if you got room, if you're close enough, you can come down into the machine and clean up any spilled powder from down in here, around this area. Now I can open this up too, take an extra look around. Now, what we can do is we can also move the build chamber back. So, I can unclip it, move this out, then I can bring this out, and I can get all the rest of that powder. Alright. Okay. There we go. And now, this is basically ready for the next print, depending if we have enough powder left. So you saw actually at the beginning, I'm gonna close that, how much powder we've got. So it used a bunch of the powder. And now that is in here. We'll do a final little cleanup, the tip of this thing. Oh, you know what? I missed one part. Let me get down there too. All right, we are still sifting, but that's pretty much done and good. So let's move on to the blast. This thing is really cool. Absolute game changer for SLS post-processing. I'm just gonna move this to the side. And then, actually it's important to note, this could just be used as a sandblaster because it's got these gloves in the box, right? So you can actually just pull this thing out. It just comes right out like that. And then you have a sandblasting chamber. But today, we're most interested in the automatic function. There we go. And she spins. Oop, there goes my finger. So now, really just dumping all the parts in there. So we've got all these parts in here, just gonna tumble around and get blasted, but not like the college kids are doing on Friday nights. A different kind of blast. So from there, all you gotta do, just position this. Now we have installed the polishing module on here, which is actually replaces this. So this is normally just a thing, but if you get the polishing module, which of course we sell at visionminer.com, then it actually makes incredible polished parts, more so than just with the bead blasting. Let's just close the door, nice and latched. And then over here, you can see we've got a bunch of different presets and things like that. So you can do long polish, short polish, aggressive, delicate, standard, short, you know. So like we might have some parts that come out of here that we want to do a little bit more, so we would do a short run on those. And you set all your PSI and everything like that. So I'm going to do standard. And then I could change the PSI or the minutes, and same with the rinse, but we're just going to leave it all at default. And then speed, of course, is how fast the tumbler's tumbling. So let's turn on the fan, and then we'll hit go. or start rather. So now it tells me 10 minutes of blasting, 5 minutes of rinsing, and it's done. So it'll start up here in just a second. So we're gonna come back in 14 minutes, 39 seconds, and we're gonna check out the parts, see how they came out, maybe do a second run, and go from there. See you in a moment. All right, we've got cycle complete, and let's open her up and take a look. All right. Now I did mid-cycle, I took this out because it was very heavy and falling all around, so I kind of wanted to throw this in on its own and see what happens to that. But, oh my gosh, gee whiz. This is with the polish cycle and everything, and these parts are looking phenomenal. Let's grab our parts bin and unload. Very cool. You know, there's blasting, and you get kind of a matte finish, but with the polishing, it's just this liquid. It's literally, it adds a tiny bit of liquid in here that comes out of this nozzle. It comes through this hose into the polishing nozzle, and I believe it makes a chemical reaction that smooths your parts. So look at that. Look at how beautiful that is. Oh my gosh. This is ridiculous. This is just, fantastic. Got these little parts with little springs. Oh yeah, this part. So it was moving around, so it got nice and polished, it looks like. Beautiful. Oh, the brake rotor. Or no, sorry, the brake caliper. This is fantastic. Wow. Okay. Got these little gears. I think these will break free. So we're gonna have to figure out how to break these free on the table. Oh man, look at that. Beautiful. Sheesh. Oh, we got a little broken corner right there. Oh well, all right. So maybe delicate parts we should put in their own blast cycle. These are beautiful, man. This is where the magnets will go for the brushless motor, and we're gonna wrap all the copper around this. That goes inside. Oh, and then here's the bottom. Here's the test. Does it screw together? Oh, yeah. Oh my gosh. That is cool. Make sure you're subscribed to see this whole project. We'll be doing it in several different materials with several different technologies to see which one actually works best. And then maybe we'll build a crazy drone. Beautiful. Oh yeah, here's those brake pads. Parts just look so good. Oh yeah, remember this part? Oh dude, and this should snap right together. Boom. Look at that. Huh. All right, we're gonna take a closer look at all these at the table. Oh dude, look at that. That's insane. This is just insane. Oh, we got our chainmail. Beautiful. Now, I'm just gonna leave this one in here. Pull this back, lock it in place. I'm gonna move this back over here. And let's just run a short polish. Let's go for it. Fan starting. All right, so this part still has a bunch of a little bit of powder inside and whatnot, so I want to make sure that I get everything out of there before we actually take it apart. So what I'm going to do is I'm actually going to just take this whole thing out. We'll put my part in there. I'm going to set this up just like this. We'll close this, and then I've got down here I've got foot pedals. This one will do air, and this one will do bead blasting. So I can just use these included handy dandy gloves right here. Grab my part, and I'm gonna start with air. See what we can get out of there. So you really do get a manual sandblaster with this. It's not just an automated function. Now let's do some beads just for good measure. I'm not seeing a bunch of dust coming out, so maybe it actually did a pretty good job. I say, let's go take it apart. Close this up, let's open her up. Take my part out, let the extra beads fall out, okay? Put And then you just want to look at where the little notch is. So you can line that notch up, the bolt back here, and it'll slot on, you'll be able to feel it. There we go. And then these two things get flush when it's fully seated. There we go. Clean it out. Good to go. All right, well, here we go. We've got all the parts. Let's check them out. All right, so we got all of these parts from half a build volume. Like, we crammed them all in there, hit one click, and it laid them out, and it literally did them all. So a couple things we're gonna look at is the circular parts that were printed on their sides, see how circular those actually turned out, the different textures. There's some very delicate parts in here, and there's some really cool stuff. So let's just dive in and look at the parts. This is definitely one of my favorites. This is absolutely nuts. This is the NASA fabric, so it's this design with all these little spiral hook things, and it's all together. So when you hold it that way, it bends that much, but here you can fold it totally in half. You can even fold this whole thing up into a hot dog or something, a roll. Look at that. It's really hard to tell on video how cool this is. It's just something else. It's just, you can do this in FDM, you can do it in SLA, but in SLS, it's just so perfect. It's incredible. I absolutely love it. We got a little one here also. Might have to do a bunch of samples of those. Let's see, we've got these parts, which are the ball valves. So it's printed in place just like this, no assembly, no nothing. And these are actually really cool, and I believe they were printed on their sides. So they'll actually thread together. Oh my gosh, yeah, that's nuts. Dude, all the way down. I don't want to go too tight. That is freaking sweet. Look at that. And printing on their side and getting a perfect circle that threads together that easily is just a testament to the engineering that's gone into this over the last few years for the Fuse system. That is very, very cool. And we did break them apart before we put them into the blast. I previously did this just on our first test run. We put them through the blast before we broke them out, and then we broke them apart. It was definitely a little bit better, more polished just overall throughout, by breaking them apart and moving them before putting them into the blast. So that's an interesting little note. So this is the little case that you can print, and it snaps, has these snaps together. That's pretty slick, a little pelican case type thing. And inside, it's got this. So this is just the little cool features. And this breaks apart because it just uses little nubs for the hinges here. So you can literally just snap them back together. And then let's assemble this thing. So this will just go, snap that right into there. Snap this side, boom, like that. Then we can connect center hinge. A beautiful sample briefcase. So they did a M8 by 1.25 thread. They did some hole sizes, some little thin wall sizes, and this was printed on the Fuse 1 Plus 30 watt in Nylon 12 powder. So this is 80 grams worth of powder. Pretty slick. So if we look at the slice and see the orientation at which the case was printed, it was likely at a slight angle, because you see that stair stepping on there? You see how it's like, you can see that? That's indicative of it being at a very slight angle, just barely at an angle, so you're actually seeing the layers of the SLS print. Now, if we had printed this perfectly flat, you wouldn't see that at all, or vertically, you wouldn't see it at all. Even more of an angle, you wouldn't see it at all. So that's an interesting little thing to keep note of when you're printing on these machines, because if your parts are slightly off, it might not come out exactly as you expected. It'll still work, it'll still be functional, it'll still be beautiful, but something to consider. We've also got this little generative design wrench. Looks like it's probably for a 10 millimeter or 12 millimeter. Just a beautiful little thing. Yeah, we'll get to this torture test here in a second, but let's check this out. So this is actually an assembly for a brushless motor. So basically inside here you put magnets, and then around this thing you're going to wrap a bunch of copper wire. And then inside also goes a bearing. So that's a project we're going to do in a future video, and a couple different materials, different technologies, SLA, SLS, FDM. Actually, I don't know if you could print this in FDM. This is so fine and complex, I don't know if this could be done. Right out the gate, I would say it shouldn't be done in FDM, unless you scaled it up. But make sure you're subscribed to see that video, let's just screw it together and see how perfectly these parts. Gosh, it's beautiful. It's beautiful. By the way, once again, if you didn't notice earlier, we do sell all this stuff on visionminer.com. We have the full gamut of 3D printing technology, as well as 3D scanners for reverse engineering and metrology inspection, and the software to power it. So if you're interested in any of that stuff, we got it. Give us a call, shoot us an email. We are here to help you figure out what the right thing is to get. All right, so we've got the Brembo brake. Now I forgot, in my planning I knew I had to print multiples of all of these, but I forgot to put in multiples, so we only have 1 bolt, 1 cotter pin, 2 pistons, but we do have the left and the right brake pads. So let's just see if these fit. So that would go in there like that. Like a glove, dude. Like it just fits like a glove. Oh my gosh, I don't know if I'm getting those out. I might have to drill a hole to get those out. Those are in there. Those are in there for good. I don't think I could. Yeah. Oh yeah. I can get them out. Look at that. Oh yeah, like a glove. We're talking, that's some tolerances, dude. Wow, that is insane. Same on this side. Put it like that, and like that. Beautiful, beautiful. Okay, and then this is the brake pad. Put that in a little bit. Should go somewhere like that. So I do need to get the other pistons printed to properly assemble this. And then the little cotter pin that you saw earlier in the video, I lost it. I don't know where that thing went. But you probably shouldn't print cotter pins on this unless you have a very specific application that needs nylon cotter pins. You can. You could do it. This would be like for fit and fitment, just, you know, if you needed a range of designs that you wanted to hold in your hand, you know, and sort of see. You can electroplate these, make them feel like metal. You can do all sorts of post-processing. We use the blast and polish, which gives it that sort of shiny look, almost shiny matte. It's like a satin finish, and you can do a lot of stuff to this material. So it's very, very cool. Beautiful. I almost forgot one part, and that's this chainmail setup. Let's see how it comes out. So you're gonna tear off this whole thing. Oh, wow. Oh, there's little supports in there. As you can see, this is all breaking isotropically. I believe there's a slight difference, but you get very near isotropic parts in this technology. Oh, look at this. Oh, no way. Is it just coming apart? Oh yeah, and we got a ton of blasting to do here. So I'm gonna do that real quick. I'm gonna go blast this lower layer, and I'll be right back. All right, so we just blasted it manually a bit more, got all that loose powder off, and I think we're just gonna run it through another automated cycle to get it nice and shiny. But let's get this last little bit. Not just snapping off easily, as expected. So this design is definitely intended for FDM. Oh yeah. It looks like, yeah, these bottom ones are just way too fused to come off. So that's not gonna happen. But beautiful chain, look at that. Freaking awesome. So hopefully one of you guys has a full file for the entire build volume, and we will print that. So now, the grand finale, let's put this crazy Rubik's Cube torture test SLS MJF part together. So this is the centerpiece, and this is where the tutorial will start, because I couldn't find anywhere online that showed how to do this. Now, one thing I learned in doing this previously was that each one of these little parts basically just snaps onto that center part. But you want to make sure that there's 4 cuts down the edges of each of these, and so you want to make sure that they're separated. And using just a razor blade, good way to make sure it's going to flex. There we go. See, there's a little bit of sintered plastic in between there. Just make sure they're all nice and broken apart. So now this will snap, boom, like that. So let's do that on all these parts real quick. That one's good, I can see light through it. Boom. Okay, so now start putting them together. All right. Okay, so now we've got 4 of them, so I can take these with the triangular sections. I can slide it in. Let's put the pig head on this side. There we go. So here, let me show you what we got on here so far. We got a brick pattern. We got a different brick pattern. We have a line pattern. We have a designed pattern. These little things, oh, you know what? I bet these spin, but I'm gonna need pliers for that to get those to move. We've got a different kind of pattern. This one, oh, thank you, sir. Oh yeah, they want to break free. Well, let me know if you want to see that in the comments below, and I'll try to break it out on Instagram. So this little area is super cool because it's just tiny little spires. I've seen people print miniature books where it's just a little book and there's a bunch of little thin pages that are just super thin, and this is sort of taking that to the next level by doing tiny little spires. You can print a broom on this thing. The little pig's head. I could see this system being really good for makers that are doing like any kind of figurines or anything like that. Probably more so than SLA. Because SLA gets all messy and whatnot compared to this where it's just tough nylon. Twist. Oop. I lost one. Oh yeah. Okay. So now we have our center. We have the center complete. Let's take I'll put a triangle. Oh, we gotta look at these as we go. So this thing is just sweet because it's 4 springs capturing that hexagon ball in the center there. Okay, so I'll put that one there. This part is very cool. This is this is almost a lattice structure, but it's like abstract. What do you call it? Almost a fractal, something like that. If you know what this is, please comment in the comments below. What is this design called? I'll put that right there. And let's take, we'll take this other one. This is like a Voronoi generative design type thing. Voronoi, like the vases and things like that. Take this thing. This is cool because it's a joystick or a ball joint. Yeah, that's a pretty neat little thing. So let's stick that one right there. We'll do the square lattice structure, which it looks like I broke when I was getting it out a little bit. Let's do little benchy here. Look at this. This is benchy on the water. That's pretty cool. And all the features came out. You got the steering wheel in there. No stair stepping. I don't see any layer lines. Little benchy boy. And then we need another corner, so we'll do the sphere lattice structure. Okay. And then we'll do the captured screw and nut. Let's see if this is functional. Oops. As I break things. Okay, I don't know if that's a functional nut. It could be. Let's see. So the captured nut and the joystick. Wow, this is one of my favorite textures. I noticed this when I was just playing with it, where if you have lighting on it and you shift it, it creates fascinating different little patterns. Really cool little thing. Now, one big thing I should mention is that the preform software for both the SLA and the SLS products from Formlabs has functions to not only hollow and create holes and do different things. So if you had a big part and you wanted to make it hollow and then shake all the loose powder out of it, you can do that right there in the slicing software. It's really cool. But they even have texturing. So you can add textures like this or like any of these to, or like this, you know, to your parts just with a click of a button. That's like a really, really cool feature because that'll give your parts just a whole different feel and vibe from a super smooth, nice 3D model, right? So that's pretty cool. So the last part, right in the middle. Oops. Ah, there we go. Torture cube. Let's do the other half. Oh, this is really cool. Delicate parts, I'm finding, should probably go separately in the blast for a different lighter cycle, because I think a lot of these little things got broken by the bigger parts that were in the blast. You know, but you can still see it came out that tiny, tiny little chainmail type. Let's see, this will go right in there. We got this one, which is another type of lattice structure, except it's just a hollow cube, which is pretty sweet. Put that right there. We'll grab one of these corners. This is another type of lattice structure. This is the type of thing you would see in cooling objects. Anything that is going to be a heat sink or something like that. This is a very high surface area. type of design. It's like a gyroid infill almost. Actually, I think this is gyroid infill. There we go. So we got another type of spherical lattice structure. Pretty cool. Stick that into there. This is one of my favorites. This thing is just impressive because it's so thin and it really is springy. That's freaking cool. Very neat. So put that in there. Another corner. So we've got this. This is another lattice. Very, very fine lattice. You used to only see this stuff in the SLA. And you can kind of do it in FDM, but nowhere near this fidelity. This is detail, and this is just super cool. You can make sieves for different types of materials using this technology. Very, very cool. I'm missing one corner piece, so we're gonna have to go look for that. This is a very cool part as well, because that has a hinge right in there, so it's just and it'll go more than 90 degrees. So you can see there, it goes all the way over there. So that goes right in like that. And then we're gonna take a quick look for the missing piece. Okay, so after further review, it looks like the file, you know how we imported that form file that was pre-made? That file was, well, let's just say it only included 7 corner pieces. So one of the pieces was missing, so there is no final corner piece, but luckily we've done this before, so I have one of the extra corner pieces here, and I'm just gonna slot that right in there, and then that one will go right in there. And then the final piece, here we go. A little bit of weight. Oh, yeah. Ha! Okay, we've got our fully assembled torture cube. This is insane. This is just, it's too much to look at. This is crazy. These should spin. Oh my gosh. Yep, you can spin everything around. I mean, this is based on the design of an actual Rubik's Cube, so it makes sense. This is so cool. Pretty awesome, very cool stuff. Anyway, thank you guys so much for watching. As usual, we do sell everything here at Vision Miner related to 3D printing, reverse engineering, and design. So we've got the FDM printers, SLA printers, SLS printers, 3D scanners for reverse engineering grade, and metrology inspection grade, and the software to drive all of that for your reverse engineering. So if you need any of that stuff, you're interested, you like watching these videos, give it a like, give it a subscribe, give us a call, shoot us an email. We're here to help. So thank you so much for watching. Have a positive rest of your day, and I'll see you on the next video. What is that?
PA12CF.
That's pretty sweet.
This is a tensile testing ASTM 655D.
I think it's 568D.
Yes, thank you.
Awesome. All right. Have a great day, guys.